Welcome to the public AI Café on February 15th. And today, my pleasure is to introduce the speaker, David Hoga. Hi, David.
Hello, everybody. Pleasure to be here.
He's the head of Smart Music with his talk on the state of music information retrieval via AI. Myself, my name is Carl McWilliams. I'm the moderator and organizer of this cafe, and the cafe is part of the European research project called AI for Media. And always the rules, please take notice that the session is already in the process of being recorded. Basically, the link for the recording you may find later on YouTube if the speaker allows it. No confidential information shall be shared in this cafe session. All speakers express their personal views and opinions. This is not necessarily the official AI for Media project opinion. So yes, again, welcome. I see you as participants also coming in. Great that you're here. The web cafe is an online forum to gain insight into the European AI scene, and you as participants get the chance to share knowledge and experience and meet stakeholders from various areas of AI research and application. So as it is interactive in the way that all the participants can send questions to us, you use the button of questions in the menu, and I will read the questions later to the speaker. So take the chance if you want to send a question. We are very happy. And after the presentation, David will answer them. So, and now I introduce the speaker, David Hoga. He has a bachelor in systematic musicology and computer science and a master in systematic musicology. And he played several roles at Phono Net GmbH, and the last role being head of digital media and business development. And since 2019, David has been the CEO and founder for MusicCube GmbH, and now since 2022, the head of Smart Music Song Trader Inclusive. So very, very exciting. We hear already there is some business in the air. So we maybe find out how you can actually make money with research. This is really interesting, and especially for all the entrepreneurs in us and with us and myself. I'm also an entrepreneur, so I'm very, very excited to hear your talk. So I will now give you the moderator role, David, and looking forward to hear your presentation. And here is the moderator role. So let's see.
Yes,
yes, we see it. We see them.
Great. Yeah, so first of all, thank you very much, Carmen. Thank you very much also to the European Union and the AI for Media project and Fraunhofer, who were mentorships, who did a mentorship for our project, which was part of the AI for Media program. I'm really happy to be here, and today I'm going to talk about MusicCube and SongTrader. I will explain a little bit more what the difference is there and what the commonalities are there. And yeah, this talk compared to earlier talks that you may have seen, or the ones that I have seen here, is most likely a little bit less technical compared to many of what I've seen, because we are not coming from academia directly and have just here, results that we can just throw out to the world, but we are a company, which means also that yeah, our goal is to use and exploit and to benefit from AI and to leverage it. So that's why I'm going to explain more what we do as a company, where and how we use AI in there, and yeah, what the features are that we can provide. So MusicCube is a company that's all around music discovery, and this music discovery can mostly be divided between B2C and B2B. Obviously, B2C, meaning business to consumer, gets interesting for streaming services and others, so that users can discover music that they did not know so far. We are focusing on B2B, meaning that companies can discover music that they did not know so far, or that they did not know that it would be perfect for them. Because in search engines for music, most of the times it's very limited features in there. You either have to know an artist or a song that you want to find by just typing in, or in terms of voice devices, you can just say what you want to hear. But what if you don't really know what you want to hear, but you have more like a rough idea about what you want to hear? So that's where we come in. So it's all about search methodology and search functionality for music. I need to learn how to do the next slide here. So yeah, here we go. Carmen already did some mention my CV basics, so I will be very short with this. I studied musicology and computer science in Hamburg, and also master. And in between, and while I was studying, also I had several roles in a company called Phononet, which is a joint venture of the music major companies, meaning Universal Music, Sony Music, Warner Music, but also some independents called indies mostly. So that means these companies founded Phononet in the early 90s in order to solve common data problems they had at the time. And remember, this was a time where digital music usage was not a thing. So it was all about, I mean, it was digital because it was on CDs, but it was physical and not on the internet, and not consumed, widely distributed. And back in the days, I was working a lot on music metadata, and while studying musicology, I was working in a field mostly that's called music information retrieval. And in 2019, I decided to found MusicCube to marry the both. Music information retrieval is a field where you mostly analyze audio and extract information out of the audio. So this can be sound information on the sound, on the musical features, and these kind of things. Metadata, on the other side, is already describing the music in several ways, because it was mostly like typed in by human persons. So title, artist information, also genre, and these kind of things. And back in the days when I was studying, the AI part was still, I would still say it was kind of avant-garde at the time. And the things I did with music information retrieval were non-AI. So it was more like you hit a button, you write an algorithm, you hit a button, and it takes you minutes. It takes the algorithm minutes to process the audio and get information out of it. Obviously, this is the AI becoming mainstream and becoming really kind of easy to use. This changed completely. And what I've seen is that the metadata world that's already around and the music information / AI world are a perfect couple, because metadata means training data. And that's where basically we found a MusicCube, and at the same time we've seen that there are just not enough music search functionalities around the world. And earlier this year, no, last year, we have already 2023. So in 2022, MusicCube was acquired by an American company called SongTrader. This was right in the middle of the AI for Media program, because they were quite interested in exactly what we did. So search functionality. There's not many companies worldwide that are doing what we are doing. There's some, but it's a very small niche of a niche, if you will. So yeah, there were certain reasons why we've seen SongTrader as a good match, and SongTrader has seen us as a good match. I will go into more detail later with this. So what are we actually doing, or why are we doing this? What problem do we solve? there was some study, I don't really have a source here, but that stated that 91% of music remains almost unheard. That means users are in filter bubbles and or echo chambers, if you will, because they only listen to music that they already know, or use playlists that are curated by certain people, or and all recommendation or most recommendation engines rely mostly on the scheme of other users have also listened to, just like you know it from all your shopping experiences online. Other customers have also bought, and this leads to the same items being pushed, whilst the most songs being under the radar of the average user. And in a B2B, oh, it's now I got, sorry, here we go. And in the B2B context, this is kind of the same, because when you are a company that wants to use music for commercials or for TV series or movies or whatever, then you are kind of in the same situation. There's experts working on that, music supervisors who are professionals in finding interesting music, but still you rely on their knowledge, gut feeling, and more. And also, there's no chance that in the more than 80 million songs that are around, you find every hidden champion in there. And also, everybody can tell you that using the newest Beyonce song for your commercial will be a huge success, but this will probably also be quite expensive. So finding hidden champions is something, especially the B2B context, that's quite interesting for music users. So what our project is, or our product is an auto tagging engine, and based on that, a semantic search and data enrichment services. So semantic search means, in our case, you can search not only for artist title, what you already know, but you can just search by descriptive tags, or by describing the music you want to search. And we can do that because we do auto tagging. That means our engine processes audio files, and describes them in right now, I think, 34 different categories that include something above 300 different tags. So this can be moods, emotions, instruments, sound features, and much more. I will go in more detail very soon. Quick insight into the tech that's in the background. As I said, I won't go too deep in that. We can do that later in the question sessions or afterwards. But what we have basically built is we have licensing deals with companies that enable us to have a database of 57 million recordings. And these recordings are mostly our training data, and they also serve for search themselves. And we have access to audio files based on these licensing deals, which we need for training. So what happens in the actual system is we have a deep CNN, and we pre-process the incoming audio file to a mail spectrogram. Mail spectrogram makes it easier to process. On the other hand, we have also an engine that processes raw audio. It's kind of, for us, it's kind of in the middle. Both have some pros and cons. Mail spectrogram obviously is a simplification because it is a spectrogram based on frequency bands you have. In this image, you may see that there's distinct lines horizontally in here, which are the frequencies of the song, while the x-axis is the time of the song. And this is what's being trained on, and this is what's being predicted on. So in the end, you can imagine this to be very comparable to image recognition, where you would also see patterns, where the engine would also see patterns in an image, just like this, only that in our case, the engine does not have to recognize whether this is a cat or a dog or whatever. but it has to recognize whether this is a happy song or a sad song or a guitar or piano, etc. And the way we do this in the training situation is that it's all based on supervised learning, meaning our main job is, besides engineering and besides building the actual models, our main job is providing perfect training data sets, both on manual basis, both also on automatic basis from the data providers we work with, and so on. So the usual game of AI, obviously, generating and collecting and curating, if you will, the necessary training data sets. Balanced, it needs to be balanced, it needs to be non-biased. We have huge biases, by the way, so obviously we are a company and we are based on certain markets, and the musicologist in me tells me that our view on music is entirely Western, and there are so many different music traditions worldwide that we need to ignore, which would be worth taking as well, but it's not just not possible due to business reasons, obviously. But yeah, that's a different story. And what happens, the result is the actual auto-tagging engine that we have, but also an embedding space with currently 500 dimensions in which every song is located. And this is also being used for similarity search. So the closer the songs are, the more similar they are. In this context, there was also the AI for Media project that we had. Just to go quickly in the AI for Media project, we made recommendations and the tagging based on a mixture of, or to put it differently, we have already the semantic search, so we can show you sad songs, happy songs. But in the AI for Media project, we managed to do this based on a user's taste. So a death metal fan would find a different sad song if we would search for sad songs than a jazz fan or a pop fan, because obviously music emotions and music perception is super subjective, and yeah, that's what we solved there via navigating through the embedding space in certain ways, calculating average vectors between the song we would have found and the song and the musical taste of the users, which is kind of a sub area of that whole space inside the 500 dimensions. So yeah, and this is just to give you a very small glimpse at what the prediction produces. You can see confusion matrices here, so meaning from the labels we predicted, how many have been correct. As I said, we have 34 categories, more than 300 tags in there, and this is just 2 of them, but very important ones, because everybody knows genre, music genre. And you can see already some weaknesses, but also some strengths in here. So for instance, you can see that we have a success rate of 69% in predicting hip hop correctly, 86% in predicting electronic music correctly, 90% classical, 91 spoken word, which is, yeah, maybe not even a music genre, 90% reggae, but also something like 32% pop in this case, which is in the end not correct, because mostly music genre is a thing that's also being used a lot of like business politically. So things are called pop that are actually more other genres. So in Germany, you would have, for instance, Schlager as something that music industry often tags as pop. In our case, Schlager would have been part of world. So in these kind of differences you have, and this is the main challenge we always have. The things we predict are almost never objective. So for instance, in image recognition, it's quite objective to say this is a cat, or this is a dog, or this is a human, or this is a car, or whatever. But in our case, it's genre is super abstract. So if you ask two people whether Schlager is world belonging to world or belonging to pop, you will get two different answers. And it's really, there's so many edge cases between them. Also, music often belongs to multiple genres, etc. So long story short, this task is both subjective and complex. However, on the right side, you can see the confusion matrix for our subgenres, which is more than 150. That's why they are not displayed there. But what you can see is that the line is quite sharp here. Subgenres, for instance, is something like, in the case of metal, black metal, death metal, thrash metal, all these kind of things. Or in the case of jazz, it's cool jazz, slow jazz, smooth jazz, these kind of really nerdy, niche, expert descriptions of music. And yeah, the engine predicts them, not perfect, but quite well. Something very new, that's why I'm showing it, that we are now doing is, and you can see here how that it's relatively low in the success rate, but also it's in this case not really sharp. What we now do predict as the newest feature we have is how much does a song sound like it was from a certain decade. So does this song sound like it was from the 80s or from the 90s, etc. It's quite interesting that this works quite well, especially the musicologist inside in me again comes in, especially in the 50s. So there was very distinct 50s sound, which can be found here. And 60s, 70s, etc. is a little bit less obvious, but you can see that we are almost always quite close, and there's always music that's kind of ahead of its time and kind of on the other hand, there's always music that's kind of retro. And we do the same now with origin regions from music. So we cluster countries in this case to different regions and say, hey, this music sounds like it was from Southern Europe or Sub-Saharan Africa and so on. Going back to the products that we have with this, I'm going to switch screens quickly. I hope you can see now my browser. If not, Carmen, please jump in. Our actual products are backend products, so we consider ourselves mainly a backend provider. We are selling an API, but we more and more go into front ends as well. And in this case, for instance, we learned that many music rights holders, meaning labels, publishers, but also composers, producers, often have large catalogs of music already. So there's really companies in the publishing space that are consisting of a few people only, but already have 100,000 songs. Or there's composers who produce who just need to compose a lot of music in order to have some of them have success, and they already have hundreds of songs. And they often lack search engines for their own music. So what we have here is that people can just drag and drop audio files, MP3 files or whatever, and we auto tag them, and they are then searchable in this UI. So in this case, you can see, for instance, here's all the tags that we generated for it, and here's on the left-hand side filters. So there's something like, I don't know, a couple of 168 songs in here, and you can filter them for a certain tempo, BPM, beats per minute. You can do something like, is this a song in major? And then you can say, from these songs that are in major, how many have female vocals? And then this is 9 songs. And from the songs that are in major and have female vocals, how many are, I don't know, dreamy? And then this is 8 songs. And then you can go ahead and search for even more fields. So in all the 34 fields, you can search as a combination in order to get the perfect song that you need for your use case. Because what those companies often have is they need to pitch their music for certain briefs, music briefs they get. So producer of an advertisement or something else comes to them and it describes pretty narrowly what music they want, and so with this engine they can just type it in and find the music, and it's yeah, really now dreamy major songs with female vocals. Something else we do is all the tags you can see, all the 34 categories are also predicted not only once per song, so in like this is a sad song, but also on smaller portions of the song. So in concrete, it's 8-second snippets. So in this case, I'm going to show you just because everybody knows this song, Highway to Hell from AC/DC, where you can see this is the time distribution. So x-axis is seconds, and the y-axis is how strong a tag is over time here. And I pre-selected the decades that I've shown you earlier. So how much does this song sound like it was from the 80s or the 90s, etc., in the different parts of the song. So you can see here there's a first part of the song, first 40 seconds, where it's obviously not quite distinct in terms of how in terms of decade sounding, if you will, but then it becomes more and more clear that this sounds a lot like the 80s. And you can also show bar charts here, which summarize how much of each decade is included in this song. And in this case, it's a very strong peak of the 1980s, and the second strongest is the 1970s. And I checked that Highway to Hell was published in 1979, so it seems to be a little bit ahead of its time because it was also a massive hit. It probably makes sense. And so remember, this is data. This is not the actual truth. This is just a prediction based on the engine which has processed the audio file. We can do this for more fields. So I will just check. Let's pick genre. I'm going to select genre here. Maybe I pick one from the main ones. So R&B. There's interestingly, it predicts some R&B features in here. I don't know why. Maybe because the singer is singing quite high. But if you compare it to rock, I have not done this before, but I would hope that, yeah, it's quite significant that this is a rock song. Or let's pick hip hop. You can see it's not hip hop at all. Maybe it's a little bit going into the metal direction. Yeah, a little bit, especially in the end when it's probably being louder and when the chorus is repeated for multiple times. So long story short, we can do this. We can point out these lines for any tag we have. So coming back to my sad example, we can also see that Highway to Hell is not sad at all, but it's probably energetic. Yeah, it is more energetic. So one other thing that we do, and this becomes more and more experimental, if you will, or something that has not been done so far, is that we are predicting target audiences of music. That means we are not only, for the first time, we are not only describing the music, which a human could also do, but the engine does it faster, by the way. So to make that, to mention that as well, the value proposition of this is not only that you can search by it, but the auto tagging, which happens a lot. Tagging in the music industry is a big thing. A lot of humans are tagging music, and it's a job nobody likes to do because as soon as you tag the 10th song, you get crazy. And tagging a song well takes you 3 minutes about. It's what we learned. Our engine needs 3 seconds. In longer songs, it needs 10 seconds or something like that. So that's the main value proposition. But coming back to the audience prediction. So first time, we do not only tag something that describes the music, but we also now tag stuff that's contextual to the music. So how does this music work for certain audiences? And what I can tell you here is, what I can show you here is, for instance, of staying with Highway to Hell, I'm going to audience gender. So we divide our audiences in 3 different fields: gender. And sorry, by the way, that this is only binary gender, but we are lacking training data to make it more diverse. So we can say what the gender, age, and geographical information of an audience is for each song. So in this case, you can imagine Highway 12 has a quite male audience. I know this is kind of a cliche in the end, but also, and there's always cases where not only male people like this kind of music, but still this is just a share between male and female audiences and or persons in the audience. And again, this is not the real audience of this real song, but this is a prediction based on training data. Besides gender, what we can do is also age, as I said. So I'm going to select age here for this song. And you can see here we cluster ages to groups, and we call them like generations. So you can see Generation Z, the really young people. Younger Generation Y people don't really identify with this kind of music. Older Generation Y people, which would be something the early 30s, I guess, identify more. But then there's a massive peak with people from Generation X, and this is younger boomers. And we made the distinction, I think, 64 or 65 or so. So there's younger people from in their 40s and until mid 60s really seem to like music like AC/DC. But then older people, even older people, really don't listen to this at all anymore. So there's a very sharp distinction here. And this is yeah, to me personally, it was quite impressive to see this for the first time as a prediction based on as a prediction and not as real audience data. I'm going to switch to other songs just to show you a little bit more. So for instance, this is, there's no title here, but this is Gangsta's Paradise. I hope everybody knows this 90s song, Gangsta's Paradise. This was a 90s hip hop song. And here again, you can see that it's quite obviously sounding like the 90s. Again, I can do something like hip hop. And it's really, really obvious hip hop music. You can always see some jittering and some uncertainties here. So it goes to down to something like 40, which may be the bridge, or I don't know. So yeah, it's not always binary yes or no, but it's quite obvious. And you can do something like vocals. I would hope, yeah, there's male vocals in there. Vocals, but probably no female vocals. Yeah, indeed. So it recognizes that there's no female vocals, but male vocals and these kind of things. Also, this is a song that some of you may know from the radio, where we are currently playing on the radio a lot, I think. And it just, again, this is a song where female audiences are much stronger than male audiences. And yeah, so that was about it, what I wanted to show today. I'm really happy to answer some of your questions. Really looking forward to have some discussions here. And thanks a lot for your presence here.
Yeah, thank you, David. It's really exciting to see, and there are questions. And again, also please, everybody who's in the cafe, think about questions, send it to us. And I have the first. I will start. When you started, I'm really curious. You said, I mean, we know that's very subjective, like what is sad and what is a happy song. And you said you can even, like for a jazz fan, it's different sadness, and for heavy metal person.
Yeah.
So again, this kind of adjective sad and happy, again, how you do it?
Yeah, it's all based on supervised learning. So we have fed into the engine thousands and thousands songs with the label, this is a sad song.
Okay.
And this is a happy song, and this is a, I don't know, calm song, and this is a powerful song, these kind of things. And we did this multiple thousand times, and the deep CNNs like work that way, that the more they are labeled that way, the more they realize what makes it a sad song, or what is a sad song, basically. So just I compare it usually to my son. I have a 4-year-old son running around here, who I remember very well explaining to him different kinds of animals. And I was very impressed when for the first time I showed him a book when he was telling me that this was a pig, but he has never seen a pig before. And I remember very distinct, because we were working on this at the time, but remember that the human brain works just like the same, repeating and repeating, and then afterwards it just knows.
Yes, yes, thank you. And now I go to the audience. Damien, he has a question. Aren't you running the risk that you match on recording profiles instead of music styles from a certain decade?
Recording profiles, I'm not sure if I understand the question correctly.
Maybe you have to, Damien, you write it once more, because I'm also wondering. Then probably means like when you recording was a different studio, no? Different ways of recording. So there, you know, all these this is basically the 50s. That was the recording style.
Yeah. So yeah, that's definitely true. That's definitely part of it. In a field like this, and this counts for almost all fields we have. It's a very, very rough simplification of the actual truth that we are predicting and training on. So is a song from the 50s depends a lot on how it was recorded, and not only on how the music in there is. So the predictions can only be as good as the training data. And so if we then there is, and also there needs to be a huge spectrum in each tag. So we need to have very unusually well produced and unusually badly produced songs in each tag, for instance, in this case. So yeah, definitely recording quality is something that's a part of this field.
Yeah. Thank you. And here, Peter. Hi, David. Thanks for the presentation. And he has maybe a less advanced question. Yet I have recently not been successful finding a reliable BPM, like beats per minute detector. Have you looked into this topic?
Yes, so we are predicting, or not predicting. BPM is a field that we don't use AI for, but we only use like digital signal processing, and it's not perfect. There's multiple reasons for that. One of it is that even BPM is something that's not super objective. One would think that it is, because there's a beat and you can count on it. But then you can ask different experts, and they will say, no, it's double time. It's not 80 BPM, it's 160. Or no, the beat is actually somewhere else, or it's halftime or whatever. So there's it's not as easy. And as soon as you go there and say, hey, this song is a slow 70 BPM song, and somebody else says, no, the feel is actually fast and it's 140, depends on interpretation of the actual music score or the sheet music, then you immediately cannot really search for it, because you are either in the very slow or in the very fast pace. And the engines and the algorithms, and ours, by the way, too, have certain weaknesses in that. So you often have this half-time, double-time issue. And I can imagine there's no simple solution to that at the moment.
Yes.
So I don't know anyone who's better than us, but I would not say we are perfect there.
Yes. Thank you. And here comes Emmanuel. Do these predictions have memory regarding the decade prediction in Never mind, this became clearer with the gangster's paradise. It's all him asking, but still, do these predictions have memory?
The live engine does not have memory, so you could not. At the moment, we have no feature to correct it, kind of, and tell it, no, this is not 90s, this is 80s. Next time it will be better in that. That's not the case at the moment. The training process obviously bases on memory, but yeah, there's no feedback in kind of at the moment. So if you correct it and if it does a mistake and you correct it, it does not remember that it was corrected in the case before. But that would be a use case that we are willing to do soon. So a self-learning ongoing experience, but currently we don't.
Yeah. Okay, and Damien once more. Damien was with a recording. Could you do a mixing table for song attributes with a life-changing list of songs according to the current settings? So you can, for example, do a bit more groovy?
Yeah, that's definitely possible. Also, this was basically part of the AI for Video project we had. So we called it AI DJ. So it generated a playlist, it played through, and then you had a drop down where you could say faster or slower, and then it would play more of that. And for each of the fields in the UI I've shown you before, there was on the left-hand side these select boxes. The API has for each of the single possibilities also a slider, so you can say something like slightly more happy or slightly faster, and these kind of things. So yeah, and we have built an auto playlist generating tool, which continuously puts in new songs in there, and you can tweak how the songs differ. But it's not publicly available at the moment.
Yeah, here comes back. I'm very interested.
Yeah,
because we want to make dance events, so I'm very interested in in this research project Carousel, and we need this kind of live. Will it be available one day? I mean, I have to stay tuned to you, or?
Yeah, so depends kind of on our roadmap. So we are too small team to make all we would like to do at once. So it's kind of at the moment we would have a hard time making it look good enough to be not embarrassed to show it to users. So in our B2B context, it's often easier to do this kind of thing for a certain customer who wants certain things. As soon as we would go with something like this in a B2C context, we would really have to spend a lot of money on it being good enough, not frustrating, on user experience and user interface and all these kind of things. So that's why we decided currently to not do that, but doesn't have to mean that's never gonna happen. So
basically a new project could come to.
We would love to do that, but it just we would need some more people. So
yes. Okay, so I have this noted, and now comes more from Holger Hus. How accurate do you believe is the ground truth you are using in the context of training predictors of audience characteristics? In particular, how objective do you think that data is?
It depends on the field. So there are fields where it's quite good, but there are also fields where it's a little bit messy, I would say. So in the audience case, it's a little bit in between. So I don't have a distinct opinion on the quality, maybe also because it's quite new and we had not really made so many evaluations on that. On other fields, there's definitely huge issues with accuracy in the ground truth. So I can tell you, not all our fields are really, really great, and we see that the more there are different issues in there. One of them is when we tag with human people, when we create our ground truth with human people, then we always do it like there's certain amount of songs that multiple people tag, and so we can understand if it's really is this a really easy task to do or not. So and we always see that even if you ask two musicologists, there's so many differences in their perception of the music. Audience is part of this problem as well, but ground truth quality is always an issue for us, and the more accurate we get, we often realize that the less balanced we get. So we're always in the process of making it wide enough, but also not losing accuracy in the ground truth. So it's our main time-consuming part of our lives. Very good question.
And here comes Jose Esteban. Gangster's Paradise is a 90s hip-hop song based on Stevie Wonder's Pastime Paradise from the 70s. Can the engine detect that? It could be applied to plagiarism.
Very good question. I did not even know that, to be honest. No, short answer, no, currently not. We looked into plagiarism detection. The main issue with that is that we first would need to have processed all the music that's around. So it's not as easy for us as to do this now, because we have not processed the words music in order to find something that somebody has done somewhere. This is something also I would love to. I could go into multiple rabbit holes here, but what is a plagiarism is also something we need to decide. Of course, there's some legal. I don't even think there's a real definition, but I'm not sure. But it's not so easy to let an engine decide that. However, I think I know that Spotify has something like that. When they let artists upload something, I think they check for something like that. So the technology is not really a huge problem, more like the distinction you make between is it a plagiarism or not. And just because so cases where a certain sample was used, modified in a certain way somewhere, this is something that we are definitely not going to do in the midterm, but obvious cases is something that's also is not so complex to do.
Yeah, I think what will you do when you find it out?
Yeah. What will you do? It's not on us. I mean, we cannot just what shall we do with that? Email this, try to find out the email of the person who composed it. I don't know. So we have no real case there. I can imagine a streaming service who needs their platform to be free of legally problematic music. They obviously have a use case and benefit from that. So
yeah. Here George comes. Hi, and thank you very much for this webinar and this opportunity. I want to ask if someone from my university, wherever your university is, perhaps wants to work in your team. What would be the right step to do? How can?
Yeah, a good right step would be write me an email. Just reach out via email or LinkedIn. I'm on LinkedIn as well. And yeah, why not? So in general, we want to grow our team. There's always chances, but it's quite specific. So at the moment, we are not super actively, but we are generally interested in onboarding more data scientists to the team, also software developers. We have a huge focus on, or had a huge focus on musicologists. So these kind of musicologists are not really open anymore in our team, but the more technical, the more interesting for us at the moment. So just reach out, please.
Okay, just send an email. And here Luciana asks, if I understand correctly, the training occurs based on sounds. Is there a predictive model for the analysis of the lyrics of the words?
There are some lyrics providers in the music industry, and lyrics is copyright. In regards to copyrights, a whole different game than the audio that what we do. So that's why we decided to not go in there so deep so far, at least. We just focused on audio. But one of the lyrics providers, I cannot name it right now, to be honest, but one of them, there's 5 of them worldwide who are really relevant. And one of them do stuff like recognition of moods inside lyrics. So I would imagine something like this is happy, sad, but maybe even ironic lyrics. So for us, it's interesting to do that. Maybe we will do that short term, but there's certain challenges, especially in regards to gathering the actual training data and being allowed to process it and these kind of things.
Yeah. Yes. So a lot of things to do in the future.
Yeah.
Barnabas, very nice presentation. There are a lot of useful features in the application. Do you have a plan to suggest to listeners earlier selection?
Earlier selection?
That's a good question.
Sorry,
Barnabas, we suggest music based on earlier feedback from the user.
Yeah. At the moment, we don't do that because in our B2B cases, it's not really relevant because the customer comes in, has a use case, needs a song, we find it, and goes. Our current B2B user wants to spend as little time as possible with us. So we don't really have a history or a feedback loop or whatever coming from the customers. In a B2C context, this would be much more interesting because obviously when you listen to music, then your taste evolves, but also the engine can get smarter and smarter the more music you listen to. That's definitely easy. But in the AI for Media project that I mentioned, where we predicted or where we searched for music based on musical taste of users, this was something that went in such a direction. So what we did there was we used the Spotify API, who could send us when the user consented to that, they could send us the top 30, the top tracks that the user has been listening to, and then we could predict based on those. But we don't do that in any business case at the moment because our customers really want to come and go as fast as possible.
I'm just curious about this customer. I mean, you don't have to tell your real customer. Is it like a supermarket chain or movie maker or?
So it's a bit complex. In our direct pre-acquisition MusicCube customership, it was mostly music rights holders. So they had their own catalog of music, send it to us, we tagged it, they could search for it in their own catalog. Now that we are at Songtrader's main customers are, you can imagine anything from, yes, supermarkets, but also car manufacturers, sports, beverages, everything, every industry who is really big enough to think about what music they use in their commercials and their corporate identity at their events, and these kind of things. So there's a huge market in there about B2B music licensing, and they always need to license music in order to be allowed to use it. Mm-hmm. And so they need to be cautious, and they cannot just go to Beyonce and ask her because it's expensive and it's maybe not be the best choice. So that's what our customers see in this value.
Yes, and then basically then all these license and all the rights to play it globally is then already clear. I mean, they know, oh, we are allowed to play it in India as well as in US and whatever, not on the internet.
So that's what Songtrader's main business is, clearing the rights, so that the user does not have to care about all these details, because there's a lot of details in the music industry licensing process.
Yes. So now we are coming slowly. You are like you must be exhausted. But one more. We have so many questions.
Yeah,
Emmanuel, once more. Is there effect-based prediction, valence, arousal, or labels? It's like in parentheses, valence, arousal, or labels throughout the whole track, rather than one label for the whole duration? I'm sorry if that was covered in the presentation, but somehow I skipped that. So is this prediction, is it several predictions in a song, or?
Yeah. So yeah, it's several small second snippets that are there. So that's why we had this curve of each single tag that's been predicted, and the tag that when we search for one tag per song for the whole duration only, then it's nothing else but the strongest of all the curves that we actually predict in the background. So yeah, that's happening second by second, basically.
Yeah, cool. And Manuel asks, Manuel, if you think about classical music, I think there are different styles of interpretation regarding on the time period. Could you predict if, for example, a symphony from Beethoven is recorded in the 50s, 60s, or other time periods?
Probably yes. I have not checked. Maybe that's even possible already. So I haven't really checked. I haven't worked so much on classical music, to be honest. We trained on it definitely, but I have not really checked the results, especially since this decade thing. I know I spent too many time on this decade field, but it's just one of 34 fields. So, and it's just the newest one. So I have not really checked that one, but I would guess yes. At least there would be tendencies in there that if you have Beethoven Ninth Symphony or so in several different decades recorded, then at least I would imagine that there's a little bit higher of a peak in each of the fields. But I haven't really checked. Very good point.
Yes. Okay, now one more, and then we are. One last is from Holger. Not one more. Do you see significant potential for approaches other than supervised learning for the kinds of tasks you mentioned? For example, for the playlist generation. So, do you see significant potential for other approaches? No?
Yeah, definitely. So we are constantly exploring completely different approaches as well. I cannot go in too much detail there, but just as an anecdote, when I was studying, and this was all still hard, if you will, then in the academia I've seen mostly unsupervised approaches. So unsupervised learning where the engine would somehow navigate or would somehow place songs on maps, etc. itself, just only based on the pure data it's being fed with, and then afterwards you could, as a human, try to make sense out of it. Also, if we consider natural language processing being added to it, then it obviously makes sense to cluster this automatically based on unsupervised learning. So yeah, the way we did it was I would say we only did it that way because it was the lowest hanging fruit, and we only had a limited amount of team members who could work on that. So there's tons and tons of different methods and approaches there. Yeah.
Yes. Yeah, I tell you, so much research, so much innovations we have to do.
That's true. Yeah.
Many ideas already of many things. And that's where also George Moratis, he was asking how to approach you. He asked, can he send you an email? I said, yes, or send it to me and I'll forward it to you. And he's from the Hellenic Open University. So
okay, yeah, please reach out anytime. I will. If it's not too many questions, I will try to be very fast with answering. But if it takes a couple of days, please accept that. But yeah, I'm super happy to get in touch with everybody who's interested.
So then again, thank you for being here, David. And it was really a pleasure. You see how much questions and how much interest you have. Also, really nice. I'm very great. I mean, really interesting what you're doing, and much success.
Very much. Thank you very much. Yeah, so it was a pleasure.
And ciao, ciao. And I sent you the recording. You decide if I can publish. I send it this evening or something. Huh?
Perfect. Yeah.
Okay.
Thank you very much.
Bye.
Bye.
Bye.